Okay, so the main idea with this question is to highlight why certain background information is important. It's also to highlight the fact that in as much as we're going to go through this question, right, and the explanation will be helpful, you're going to always bump into questions like this, where if you don't really know, the depth of the question, you'll always just bump into problems. But anyways, let me just explain and show you what I'm trying to say. So we have whatever we have here, right? It's a parabola and then an exponential graph, but our parabola is the main issue here. So they wanted us to show that Q is equal to 2. Well, that's not our main issue with this question. I'm actually focused more on like 4.3 over there. So this is technically our equation, right? Because they say Q is a 2. However, for 4.3, we actually do need 4.1. We also do need 4.2. 4.2 are write down the coordinates of the turning point of G. So getting the coordinates of the turning point, that's also not an issue because our value here, you always take the opposite of this and you always take this one as it is. This is our turning point, right? This is our value of D. However, out of curiosity, right? If let's say you are wondering how we got Q. So with Q, what you do know is, remember Q, it's a variable in our equation here. So if you have a coordinate that the graph passes through, you'll be good to go. And one coordinate that the graph does pass through is this over here. We do know that this value, the x value is a 0. Automatically, we know that the y value is a 1. Reason being, this is also a point where the graph of f of x cuts the y-axis. So in this equation of an exponential graph, we know that x here is a 0. So if you put x there as 0, you're going to get here the y value is a positive 1. So that y value there, that's the y value of c, which is what you can use in this equation to get q. That's how you get the 2 there. So yeah, that's not so bad, right? But with 4.3 rather, I'm not sure what the marker location is. I got this image just now, but okay, not just now, a while ago actually. But I mean, marker location, this could easily be like a 3-mark question. And here's the reason. So it says determine the values of t for which g of x is equal to t. Wait, determine the values of t for which g of x is equal to t. Determine the values of t for this if the roots are equal. Okay, so we need to determine the values of t for this equation if the roots are equal. So firstly, this equation is g of x is equal to t, right? So g of x, remember, it is just negative x. Hold on. So we're dealing with negative x here. Negative bracket, negative 1 here. Squared plus 2, right, equal to t. This is the equation we're dealing with. Now, what you want to keep in mind here is if the t goes to the left, you're going to have here x minus 1 squared, and then 2 minus t equal to 0. So this is showing you that t has an effect on the y value of the turning point. I'll repeat. What we are seeing here is that t has an effect on the y value of our turning point. You see, this is clearly representing the y value of the turning point. You see, it's the y value of the turning point. You see, so t is technically going to move the graph up or down. You see, because if t here is a negative value, you're going to have a negative times a negative, which is a plus, meaning that the graph would move upwards. However, if t is a positive number, you would have a negative times a positive here, meaning that the graph would actually be moving downwards. So with the question, it says determine the values of t for which this equation, no, determine the values of t for this equation if the roots are equal. So that's the other portion of the question, right? Roots being equal. And a better understanding of this question, you can imagine it's not just going to happen from us just answering this question alone. You need to go through like different kinds of questions that will allow you to like bump into these kinds of thinking, and then over time it will be normal for you to like answer them. But anyways, if they're talking about roots being equal, right, let's just use the initial picture that we have. So looking at the picture that we have, right, you can see that we have one x-intercept here and another x-intercept. So originally you have 2 roots, you see. and these two roots are not equal. You see, you have two roots that are not equal. However, a scenario where you have roots that are equal, it's literally a scenario where your parabola has a turning point at an x-intercept, because the equation of this parabola, right, whenever you like factorize it, these two brackets would be exactly the same, you see. So in our case, for this graph to have two roots that are equal, its turning point will have to be at the x-axis, you see. So what we do know about D, well, firstly, but yeah, we do need to get D first, and then this question will make better sense in terms of us carrying on to work it out. But for now, let's just maybe carry on. So if two roots are equal, it's a scenario where you have the x-intercept being the turning point. This is what's classified as two roots that are equal, because the equation of this function, right, if it is factorized, you would have something like x minus 2 here and then x minus 2 again. Meaning when you solve for x, you'd get x is equal to 2 or x is equal to 2 again, you see. That's what they classify as roots that are equal. So in our case, what we need to keep in mind is we need to ask ourselves, from this image here, what needs to happen for you to have this image? Now, from this image to have a turning point that's at the x-axis, your graph has to be moved a certain amount of units downwards. You see, your graph has to be moved a certain amount of units downwards. So clearly we need to find out what is this distance that our graph needs to be moved downwards for it to have roots that are equal. This is where the t value comes in, you see. So t is going to determine how many units downwards your graph needs to be moved for it to have roots that are equal. So we need to find out what this distance is. Now, us finding out what this distance is, that's where 4.2 comes into play, because 4.2, remember, they were asking us for the turning point of G. So we need the turning point of G because, oh yeah, we did get G. We need the turning point of the graph G, of which we did get it. How did I forget that so fast? So the y value is a 2, meaning that this distance here is a 2. And the x value is what you call, it's a positive 1. I don't think the x value really matters in this case, because they're not asking specifically for the root. They're asking what value of t would result in us having those roots that are equal. So in this case, remember, this is just an example, you know. But anyways, in this case, our graph has to be moved 2 units downwards. So here we'll have to say t is equal to 2, because look at the question: determine the values of t for g of x is equal to t if the roots are equal. So it's just actually one value of t for the roots to be equal. You know, t has to be equal to 2. This is just a suggestion to say you may have one answer or multiple, but we only just have one answer. Now, the one thing I safely do recommend here, if you've gotten this far, then you can see that here I'm not just trying to plug myself here. I'm literally trying to say, if you see that, okay, fine, you understood this question. One thing you should realize is there are plenty more questions like this that a person needs to know how to answer. And one thing I do recommend is the online course platform, you see. Courses, it's actually courses.brightyoungbrains.co.za. You see, there's like courses on the entire syllabus. And things like the functions and graphs course definitely works on what you may call these kinds of questions, like multiple examples that will leave you in such a way that you will be confident enough to go through these kinds of questions. So you can just check the link in the description, courses.brightyoungbrains.co.za. It's just a T. There we go. But anyways, that's that from my side. And I mean, like, you know, these recorded Zoom sessions, we do have like a totally different, what you call, no, I mean, like for during the week, right, we have like group sessions. And what you call, if you need access to the group sessions, I mean, on IG, just search, I mean, no, on YouTube rather, just search maths grade. Hey, come on, man. Grade 12 Zoom sessions. That's like the third channel. And then if you go to the homepage of that channel, right, you will get the meeting details of the group sessions that take place every Tuesdays at 6:30 and every Thursdays at 6:30. You get those details there on this channel. The name of the channel is Maths Grade 12 Zoom sessions. Anyways, that's that from my side. Let me stop blabbing now. Let me stop blabbing now and check out.